this will be useful for those who do not have a GPU. Those have GPU, no problem. I know that you did a CD, right? No problem. Asking you, do you know how to use it in your collab?
Sir, actually there's a one line that requires to run the PC. It's not here. I did it.
You did it. Are you able to?
My file size, my file path is not inside the collab, so I couldn't do it.
What?
Because I sent my picture in my PC, it's not inside the collab.
Yeah, but you can upload it, right? You can upload it because it gives you about, I think.
I just cannot read the image because the image is not inside the collab.
I understand. You have to upload. There's an upload button. Every time you instantiate a node in Colab, it gives you 13 gigabyte of memory. 15 or 13, I can't remember. So you have enough space. You can put up the picture. Anyway, this picture is very small. It's only maybe 4 bytes only, right? So you just upload the picture in. Okay, maybe I'll show you. But my question is, have you tried OpenCV in Colab?
Yes. But
You succeeded.
I can run that, but cannot read the file.
Thank you very much. Let me show you. Okay, you don't have to install OpenCV because OpenCV is already in here. It's already inside. I just want to know whether you know how to use the OpenCV. Okay, when you want to put the picture in, right? This is what you need to do. Just click here. Sorry, click here. This button. That's it. Okay? You just upload your picture. Open up the file. Let's say, I'm not sure whether any picture is there. You can, let's say this is a picture, because it's not picture, it's PDF. I can open and upload it. So, you see how big is the memory? The size that is given to you? 76 gigabyte. Okay, you can put a lot of pictures in here and then process it. Okay, I think you also do OpenCV, right? Have you tried this?
On my computer.
No, not on your computer. I don't think you did on your computer. Can you try on here?
I didn't try on Collab.
Yeah, you try to put it into your Colab, and then you upload your picture in, and then try to process it. Okay? Of course, it's easy because you have done that before. I think for you, no problem, because this is a much simpler problem than what you've done before. Yeah, this one. Okay? The formula is this. Very simple. Try to do this for grayscale. This is to convert to grayscale. Just now, a student, I'm not sure whether it's here or not, you need to convert to grayscale. Who is the person? The one that do the pictures. Just program something. Yeah. You can use this to convert to grayscale. The color, convert to grayscale first. After grayscale already, then only you process it.
But the other CPU, just now didn't show.
You've done this part here. So you do this and then you enhance it and then you compare it to whether there's any enhancement. Right? Okay, so this is the simple one. The more difficult one, actually is not really difficult, is to make it blur. Okay, to make it blur, if you're able to do this, I'm pretty sure that you can do the exam. Because the exam is much simpler than this question.
I can blur at the exam, sir. I can blur here at the exam.
Don't apply this, don't memorize this and go in the exam to write this answer, because my question is not this. My question is different. But what I'm saying here is, if you're able to do this, you're able to do the exam question. Okay, in my question, there's only one column. Here there are two columns here. Okay? Right? But please don't memorize this, because my question is different from this. Right? Because you memorize, you go in, you sure not good answer for you? Because my question is not this. My question is something else. What I'm trying to say here is, if you're able to do this, you should be able to do the exam question. Because this one is more difficult. This one actually is 2D, 2 dimension. My one is 1 dimension. Okay? So try these two, and let me know if you succeed. Okay, the grayscale, the code actually is here. The code is given to you. Okay? Actually, this is a complete code, right? But for this one is not given in full. Is it given in full? No, actually it's given in full. Yeah. But something is missing there. Blur size is not given. I think blur size is 1. If I'm not mistaken, the blur size is 1. You can try to. Okay. Actually, you can specify it. If you put your blur size is 1, you see it blur, but it's not so blur. If you put 2, you see it's blurred. The larger this blur size, the blurrer the image will be. Right? So you can try with different size. Start with 1, and then try to increase to different sizes, and you see the result with different result. Okay? And in fact, the answer is already given here. But what we need to do is to understand what is going on here. Is that okay? Right? And also try to understand why we have this kind of condition. Right? Because if you understand the condition, then there should not be any problem. Okay? Okay, use OpenCV to open the picture and then apply this kernel. And okay, you can try with single thread because SCUDA also can have single thread. That means the block size is 1, the grid size is 1, so it's single thread. Okay, and then you try different combination and see whether any performance gain from that. Okay, compared with a single thread. So here you don't have to run using CPU. You just run everything in GPU. You just change the size of the thread and the grid size. Okay, if you set 1, 1, I mean block size 1, grid size 1, it's basically executing using 1 thread. Okay? Okay, so that will answer your first question. The second coding part is related to the earlier chapter, which is this. This one. Is related to pipe. Okay. How do you implement this pipe? Using mutex and semaphore. Okay. How do you implement pipe using mutex and binary semaphore? Now, in order to do this exercise, you can use track by H. Okay, you use track by H and try to implement it. So you got one consumer, this is consumer, this is producer already. So this direction. So you send the part and then the other part is through the receiver. Okay, you implement it using one mutex and multiple semaphore, two semaphore in this case. Okay, so that is the only programming that I remember. Okay, the other one is related to Banker's algorithm. Banker's algorithm. Now, this part which I talk about the implementation is not full program. I mean, it's not full question. It's only half the question. Okay, the rest of the question is related to mutex semaphore. So you have to study the mutex. So mutex semaphore is one whole complete question, but inside there got one component part which is half the marks. The rest is all theory. Okay? And then Banker's algorithm, I think is full So if you don't know, please go and study. I put a link to the video, right? Go through that video. If you are able to understand that video, you try a number of exercise, you should be able to answer the question. Okay? Because the question is interesting. Then full question of video. So 3 areas. The other one, I can't remember. I have to go back and find out. Okay, I think this is the first question. I think is related to chapter number 1. Okay, it's more of a theory. Okay, I'll mention to you later. So these three parts is the one that I remember. Okay, and that will cover 3 questions. Okay, any other question?
So which chapter can skip?
10 and 11.
I already mentioned to you what will come out. The rest you go and think yourself. Okay?
10 and 11.
Okay, any other question? Yeah.
So, can I borrow the marker pen a little bit?
Okay, you can read already. Actually, he just asked me a question about his assignment. Have you signed in?